Hello and thanks for joining me for this session. Fault injection mechanisms are used to test the failure recovery capacity of your application. In this lab, we will learn how to forcefully induce faults in our application and observe its behavior under error conditions. Let's get started. You can inject two types of faults, both configured using a virtual service. They are delays and aborts. In this lab, we will focus on delays. So what are delays? Delays are timing failures. They mimic increased network latency or an overloaded upstream service. We will build on our previous lab and inject a 5-second delay in the customer's application if the request contains a header with the name as user and value as Adam. In case the header with the name user contains any other value or the request does not contain a header with the name as user, then there will be no delay. Let's delete the current virtual service called customers vs v1. Let's create a new virtual service definition as follows. Here you see we have extended the HTTP rule that sends the requests to v2. We have configured a delay of 5 seconds for 100% of the requests sent to v2. Let's create this virtual service. Let's access the API through the ingress gateway by passing the header named user with the value as Adam. The response shows the country information, which proves that the request was routed to v2, and you can see that the response time is approximately 5 seconds. Let's access the API by passing the header named user with the value as Eve. The absence of the country information proves that the request was routed to v1, and you see that the response was returned without any delay. If the request is triggered without any custom headers, we will see the same result. Let's trigger 5 requests matching each scenario in a loop. This would mean 5 requests are routed to customers v2 and 10 requests are routed to customers v1. Let's observe the graph in Kiali. If we click on customers v2 and check the traces tab, we will see the response time for all the 5 requests is approximately 5 seconds. Whereas when we click on customers v1, we see that all the 10 requests were completed in a matter of few milliseconds. Let's change the behavior slightly by configuring the delay to only 40% of the requests. To do that, let's edit the virtual service definition and change the delay percentage from 100 to 40. Let's hit 20 requests with the value Adam in the custom header. You will observe that some of the requests complete immediately, whereas others are impacted by the injected delay. If you run the loop for a fair amount of time, the traffic distribution with the injected delay will be approximately 40%. Well, that's it for this lab. Hope you liked it, and I'll see you in the next one.